Good morning, sunshines. Wanted to check in with you for your week 2 work and make sure that you knew what to do. When you log into your Schoology and you get to your biology class, you see there's week 1 biomes research. Just a reminder, it's due Thursday this week. Then we have week 2 population ecology and graphing, and this is what I want to go over with you today. When you click on the folder, there are 2 assignments in there. The first one is week 2, population ecology and graphing, and the second one is population ecology discussion questions. We're going to start with this one. It gives you some directions here. It says to complete the worksheet, including creating graphs for part 1, there'll be 1 graph. Part 2, you'll have 6 graphs to make. And part 3, 1 graph. That means to do this assignment, you're going to make me a total of 8 graphs. You can handwrite the graphs or you can make digital graphs if you know how, but I don't think I can teach you virtually how to make a digital graph. So if you don't know how, just go ahead and handwrite it, then take pictures to submit. Over here on your side, mine says submissions and it's waiting for some of you to turn things in, but yours should have a link to be able to submit, and that's where you're going to send in your pictures or your graphs. Down here at the bottom is your data that you're going to be graphing. If you click on this one, it's going to download your file, but if you click view, it should just open up in another tab so you can see it on the web. All right, here's our graph, or our worksheet. We have procedure, distribute copies of the student worksheet and graph paper to each student. I don't have graph paper to give you. You can just write it on lined paper or blank white paper. It's up to you. If you don't know how to make your digital graphs, remember, make sure that you just do them on paper. Second step. Look at part 2 and part 3, and then there's a little paragraph here. A population graph shows what happens to the population of a certain species over time. The x-axis shows the passage of time. The farther you go to the right, the more time elapses. The y-axis shows population size. As you go up the axis, the population increases. The scales for both population and time are determined by the data. So we'll look at graphs in a second, and I'll do a practice one with you to make sure you know what to do. The number 3 says give the students time to plot the data in parts 2 and 3. They have about a week and a half, so I think that's a lot of time. And number 4, once you've gone over your graphs, then you're going to do the discussion questions. Once everybody's turned it in, we can go over the answers. Here are your discussion questions. There are 10 of them. And I just want to go back to point out these 10 discussion questions are on paper, but back here in the week 2 folder, I typed the discussion questions here. When you go in to that puzzle piece assignment, here are your questions. Can you think of other situations where growth occurs arithmetically? And you go back to this one. Can you think of other situations where growth occurs arithmetically? So we've got the same question. It's written on this piece of paper, but I want you to answer the question on Schoology on that puzzle piece assignment. All right, into our graphs. Part 1 has 1, 2, 3 questions, and it asks you to just make 1 graph from this. So you have to pay attention to what you're graphing. Number 1, if you had $100 and added $10 to it the first year and each successive year, how much money would you have after 5 years and after 10 years? So they want you to fill out this little chart right here to see what would happen. If you start with $100, you add 10, you get 110. At 2 years, you'd have $120, so on and so forth. Then it wants you to look at it as a percent. If you had $100 and it grew by 10% each year, your money would grow on an ever-increasing basis. How much money would you have after 5 years and after 10 years? 10% of $100 is $10. We just move the decimal place over to the left one. So we add $10, we get this. But now 10% of $110 is 11. So when we get to year 2, we actually have $121, not 120 like we had up here. If you don't know how to do 10%, use your calculator and it can help you out with that. But the easiest way to do it is to move your decimal over to the left one place, and that's what 10% would be. You're going to make a graph with the data from number 1, and then this one, number 2, says you're going to add a second line to show how this money would grow over 10 years. So I'm going to show you here how to make a graph. And they told you in the beginning directions that your time would always go on your x-axis. That's your axis down here at the bottom, your horizontal axis. And the time in this case is years. You can't just write time there, you need to write years. So this was, let me go back and check the data. We start at year 0, and after 1 year, 2 years, all the way up to 10 years. So 0, 1, 2, all right, there's our years. And then we're going to put the amount of money that we have on our y-axis. This is our population, and our money is always in $100 increments, right? It starts with $100, so we could write money over here, and then we would start down here with $100, and you could say maybe 110, 120. I didn't give myself enough room, did I? You'd have to make your graph a little bit bigger so it can all fit in there. So then let's look back. With year 1, we went from $100 to $110. And then year 2 went to 120, year 3 went to 130, 140, 150, 160, then I ran out of room. But with the second question that says it increased by 10%, we started at 100, we went to 110, but then over here we go to 121. By the time we get to year 3, we would add 121 plus $12.10, so we would get to 133.10. You see our colors start to separate a little bit there, and then you have to give a key. So the blue dot was for question 2, which was a 10% increase, and the red dot was for a $10 increase. All right, let's go back to our directions. Jefferson Middle School has 1,000 students. This is number 3. Jefferson Middle School has 1,000 students. A new housing development is being built nearby and is predicted that the school population will increase 10% each year for 7 years. How many students will there be in the school in 7 years? So this one wants you to fill out the chart, but you don't have any graph to turn in for that question. Part 2 is a little more complicated. The naturalist's dilemma. Your aunt left a stack of her papers with you while she was traveling in the wilderness. These papers include important population data that she has gathered on the species she's studied over the years. She's due back in town today, so you want to give her papers back to her, but they've gotten all mixed up. You have the data and you know the list of species, but you can't tell what data goes with what species. By graphing the population data for each species, you'll be able to sort it out. So your species list, you have Bacteria X, a cerulean warbler, a bristlecone pine, an eastern cottontail, a red fox, and bacteria X in the second population. And then it gives you a little description about each one. And then it tells you where they're studied, like Central Maryland, Eastern California, in a lab test tube. And then down here is the population data. Notice it just says species 1, 2, 3, 4, 5, and 6. But you don't know that species 1 is bacteria X. What you have to do is graph this data, and then question 4 wants you to figure out what species belongs to each set of data. We can do another example of that one. All right, so this one says year, species 1 goes by year. Let's do species 2 because it goes by date, not by year, so we can see a little bit of difference from this graph and the other graph that we did. Notice your dates don't go in the same amount of time increment. So we're going from January 1st to April 2nd to September 3rd to, July 3rd to October 1st and January 2nd. There's not the same amount of time in between each one of these, but it's pretty close. It's about every 3 months. So when you go over here to your graph, we're going to go with date as our title here, and it starts with our first date of January 1st, 1991. Let's see when our data goes up to 1999. This one is 1/1/91. Then 3 months later was 4/2/91. I'm just going to graph these first 2 points for you. We have a population of 80 and a population of 35. In order to figure out what goes on the y-axis, you have to look at all of your numbers here and make sure that your y-axis goes up as high as it needs to. Looks like our highest number, 82. Okay, so then on our graph, we need to make sure we go up to at least 85. So then I think the best way to go through it would be to count by fives. We'd have, and our populations were 80 and 35. So at the beginning we had 80, then the next month we had 35. You would keep going. Remember we had our title down here that it was our date, and we went from 1991 to 1999. Don't forget to label this one. This was your population over here, and then you have to figure out what the species is to go with that one. You would do the same, but you have to pay attention to what goes on your x-axis. For species 3 and species 5, it goes by day. For species 2 and species 6, it goes by the date. And then for species 4, it goes by the month and year. Species 1, it goes by year. That matters for your axes. Part 3 says plot the growth curve for humans using data from the last 2,000 years. So they give you the population in millions from 1 AD all the way up to 1999, and you're going to make a graph of that one. Once you finish all your graphs, you'll go back over here to Schoology. And here in population ecology graphing, that's where, remember, you're going to submit your graphs. Then the discussion questions you'll answer over here in this assignment with the puzzle piece. I hope this video helped some. If you need anything or you have any questions, let me know. I'll do my best. I tried to explain it really well, but it's awkward talking to a computer and not talking to each one of you. I'm always here if you need anything, though, so just give me a holler, let me know. Miss Densmore, our student teacher, is going to be making a video for next week's lesson and making sure that you know what to do for that one. But she and I are both available to help if you have questions. Talk to you soon.